Hello everyone, a very good evening to all. Myself, Vivekananda Naik. I am a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. I welcome you all once again for this fifth interaction session on the course Experimental Physics 1, which is being taught by NPTEL this July 2025 session with course code NOC 25 PH51. So today we will be solving a few problems that will be based on the course content of week 5, which mainly covers if you see the lectures of week 5, we can see the experiments that were discussed in week 5 were determination of Young's modulus of elasticity by Fletcher's method, then spring constant of a given spring where both static method and dynamic method are discussed, and then moment of inertia of a flywheel, how to calculate moment of inertia of a flywheel, what are the significance of moment of inertia and moment of inertia of different objects, that were also discussed in the week's lecture. So if we talk about the Young's modulus of elasticity, in the last interaction session, that is the week 4th interaction session last Friday, we discussed a few problems that was based on the Young's modulus of elasticity. Now, so in order to revise the concept that we discussed that day, so if we talk about the property of elasticity, basically elasticity is the response of a body to an applied force or torque. So what is elasticity? Basically elasticity is the response of a body to an applied force or torque. So there are mainly three types of bodies, three types of materials. So materials on basis of elasticity, we can classify materials into three types. One is rigid body, then two is elastic body, and three is plastic body. And if you define stress, stress is known as the deforming force per unit area. Then type of stress can be of different types. One is normal stress, another is tangential stress. Normal stress, tangential stress, and strain. Strain is defined as the ratio of change in dimension to the original dimension of the body. So due to the application of stress, there is strain. So there are different types of strain. So one is longitudinal strain, then two is volumetric strain, three is shear strain, and the fourth one is lateral strain. And according to Hooke's law, if we discuss, so stress is direct proportional to strain. So there comes the elasticity constant, or there is a constant which is called as modulus of elasticity. So stress by strain is equal to constant which is called as modulus of elasticity or elastic modulus. So since we have different types of stress and strain, similarly we have different types of modulus of elasticity. So mainly there are three types of modulus of elasticity. One is Young's modulus of elasticity, Young's modulus, which is denoted as Y, which is longitudinal stress by longitudinal strain. So longitudinal stress by longitudinal strain. Then uh, Young's modulus of elasticity, rigidity modulus of elasticity, which is known as B. So stress by strain, which is bulk stress, then volumetric strain. Then another is bulk modulus for shear strain. This is called as shear stress. Sorry. So this is shear stress by shear strain. So depending upon the types of stress and strain, the modulus of elasticity is defined. Then so let's solve a few problems that is based on the concept of modulus of elasticity. So um, although we have solved a few problems in the last introduction, we will solving a few problems. So the question says, the first question of the day: a beam of metal supported at the two ends is loaded at the center. The depression at the center is proportional to option A 2 by y, option B y, option C 1 by y, or option D y square. Where we all know what is y. Y is Young's modulus of elasticity. Young's modulus of elasticity. So, question is based on the experiment which was discussed in the week's lecture. So, what is the scenario? A beam of metal. So, there is a metal beam. Suppose this is a metal beam, and this metal beam is supported at the two ends. Suppose this is the support which is being provided at the two ends. Then and it is loaded at the center. So in center there some load is provided here, and due to this load and due to the property of elasticity there will be depression. So suppose this was the initial central line, and due to the application of the load it became like this. So this is the depression at the center. So this is the depression at the center. So we need to find out if this is the depression, then whether that will be proportional to 2 by y or 1 by y or y square. So I'll give you a few minutes, then we will discuss what will be the correct answer. we discuss the experiment, so we know if so in the week's lecture we discussed how to perform the experiment, and there, so suppose L is the length of the metal beam, width or breadth is B, depth or thickness is D, then this the condition for the metal beam should be L should be very greater than B, which will be very greater than D. So this is the condition for bar or metal beam. And there the working formula was Y, the Young's modulus of velocity is G LQ divided by 4 B DQ into M by L, where M is the load at the center, L, this L is nothing but the depression at the center. And we all know G is acceleration due to gravity. So if we rearrange, so L will be G mg LQ mg LQ divided by 4 Y B DQ, or we know weight is called as mg, that is weight. So L will be WLQ divided by 4 Y B DQ. So L is proportional to 1 by Y. That is, L is inversely proportional to Y. So the correct answer will be option C. The depression at the center is proportional to 1 by Y. I hope this is clear to everyone. Now we move to question number 2. So question number 2 says, which of the following quantities doesn't have the unit of force per unit area? So unit is force per unit area. So which of the following quantities doesn't have the unit of force per unit area? Options are option A, stress, option B, strain, option C, Young's modulus, or option D, pressure. So we will discuss in 2 minutes. You can think of the question, what will be the correct answer. So we know, let's consider first stress. So stress, we know it, stress is nothing but force per unit area. So stress is correct because the question says which quantity does not have. Then strain, strain is relative change, change in length to original length. So again length by length. So it is unitless. Then for Young's modulus, for Young's modulus, we know Y is stress by strain. So stress is F by A and strain is unitless. So the unit of Young's modulus is also force per unit area. And again the option D, that is pressure. Pressure we also know pressure is nothing but force per unit area. So the correct answer is strain, and strain does not have the unit of force per unit area because strain is unitless or dimensionless, we can say. I hope this is clear. This was a bit straightforward question. Now let's come to question number 3. The question says the stress strain curves of 3 wires of different materials P, Q and R are shown in the figure. The modulus of elasticity is highest for, options are option A P, option B Q, option C R, and option D. No conclusion can be drawn from the given graphs. So these are the 4 options. This is a really good question where from the graph we can determine whether the where P, Q or R for which the modulus of elasticity is highest. So I'll give you a few minutes and then we will discuss. So if we discuss, so we know how we will determine the modulus of elasticity. The modulus of elasticity formula is given by modulus of elasticity. Suppose E is given by stress by strain. So E is directly proportional to stress when strain is constant, and E is inversely proportional to strain when stress is constant. So the question, so this is the question, this is x, this is y. So along x axis is stress, along y axis strain. This is P, this is Q, this is R. So now in order to determine whether P has the highest modulus of elasticity, Q or R, we need to fix either stress or strain. So in order to fix, so if we are drawing a vertical line, then it will be at constant stress. If we are drawing a horizontal line, it will be at constant stress. Sorry, horizontal line, it will be at is constant value of strain. So let's draw a, since the drawing of vertical line will be easier and we can connect the three lines P, Q and R. So this is the point. Suppose this is O and this is N. So ON is the value of stress. So for this ON stress, so when we draw this line, then this line is intersecting the line P, Q and R at 3 points. Suppose these points are A, B and C. This is O capital A, O capital B, O capital C. So OA is the value of strain. So OA is the value of strain for P. OB is the value of strain for Q, and OC is the value of strain for R. So now since stress is constant, E is inversely proportional to strain. So the wire that has lesser strain will be having higher value of modulus of elasticity. So for P, OA is strain which is minimum, as you can see from this figure clearly, because OA is less than OB is less than OC. OA is for P, OB is for Q and OC is for R. So for P, since strain is minimum, so E is maximum for P, because E is stress by strain and strain is minimum for P. So the correct answer will be P, which is option A. I hope this is clear now. So in order to determine the modulus of elasticity, we need to know the value of stress and the value of strain. So since there are three wires, so we need to fix at least one of the quantity, that is either stress or strain. So when we draw a vertical line, then it will be at constant stress. So then the quantity, then the wire having minimum strain will be having maximum value of modulus of elasticity, because modulus of elasticity is inversely proportional to strain. So according to that concept, we found P has maximum value of modulus of elasticity. I hope this is clear to everyone. Now we move to question number 4. Question number 4 says the rate of change in potential energy with elongation x for a spring is. So suppose there is a spring, the rate of change of potential energy, that is du by dx and elongation x. So x is elongation. So which of the figure correctly represents the relationship between the rate of change of potential energy and elongation x? So this is figure 1. So this is option A, B, C and D. So x is along x axis and du by dx is along y axis. So the 4 options are given and we need to find out what will be the correct representation of the dependence or the relationship between du by dx and x. So I'll give you a few minutes to think about this and find out the correct one, and then we will discuss what will be the correct answer. So if we discuss, now let's consider the case of a spring, because the question is related to a spring. So when suppose this is a spring, the spring, the mass of the spring is negligible, and the weight, this is weight mg. So this force is nothing but mg. So when this force is applied, then the elongation produced is x, and we know the potential energy U is given by half kx square, because the F is direct proportional to, so x is direct proportional to F, but F is equals to minus kx. Then if we take the integration f dot dx, it will be minus kx dot dx. So F, so U will be half kx square. So when U is half kx square, then du by dx will be half k into 2x. So du by dx will be kx. So since du by dx is kx, so du by dx is direct proportional to x. And in the uh, interaction session where we are discussing about the basic concepts of graph plotting, and there we found when y is direct proportional to x, then it's a straight line. So what will be the correct option? The correct option will be figure IB, because this shows y is direct proportional to x. So the correct option will be option D. The option D is the correct answer. I hope this is clear to everyone. Now we will move to question number 5. So question number 5 is similar to the types of question that we solved before. It says the load elongation graphs. There was stress strain graph. Here is load elongation graph. So the load elongation graph for 4 springs A, B, C, and D are shown. Which spring has least value of spring constant? So least value of spring constant. A, B, C, D. These are the 4 options. So I'll give you a few minutes to think about this question and identify the correct answer, and then you will discuss. So if we, so here load and elongation. So elongation is x, load is f. So f is along y axis and elongation is along x axis. So as we discussed in the previous question, f is right proportional to x, or the mod of f is called as kx. So the value of k is f by x. So k is right proportional to f at constant x, and k is inversely proportional to x at constant f. So now if we see the graph, this is x elongation, then f, a b c d. So a b c d, a b c and d. So if we draw a line here, so question says which spring has least value of spring constant. So O, suppose this is n, so On is equal to x, which is called as the elongation is constant. Now since x is constant, k is direct proportional to f, so the springs for which f is maximum, it will be having maximum k. So for, if you see the image, for a, f is minimum. For a, f is minimum, that implies k is minimum. So the correct answer is A, that is option A. I hope this is clear to you. So here the graph was given between load and elongation. So since for a constant load, spring constant is right proportional to the force applied. So when we draw a vertical line at constant x, then for all ABCD the elongation is constant, and the for which the spring for which f is maximum, it will be having maximum spring constant. F is minimum, it will be having minimum spring constant. So here if you see, a is having minimum value of f, so a is having least value of spring constant. So the correct answer will be option A. So I hope this is clear to you. Now we move to question number 6. So question number 6 is similar to the question that we solved, but here the quantity that we need to find out is different. So the question says the load versus elongation graph for 4 wires of the same material and of same length is shown in the figure. Which wire has the least area cross section? So options are option A, B, C and D. There are 4 wires. The graph is between elongation and load. Material is same and length is same, and we need to find out which has least area cross section. Least area of cross section. So I'll give you a few minutes to think about this question, and then we will discuss what will be the correct answer. So let's discuss this question. So in the figure there are four wires of same material. So here you see, here there is no spring, so there is wire. So here we will apply the concept of modulus of elasticity, and for wires we know the modulus of elasticity is known as Young's modulus of elasticity. So we know Young's modulus of elasticity given by stress by strain. Strain is small l by capital L, or we can say Y is A capital L by A small l, or L is F capital L by AY. So this is the relation. Now the question says which wire has least area of cross section. So same wire material, that implies Y is same for A, B, C, D, and also it is given the length is same, so capital L, this is same for the 4. So length is also same and Y is same. Now the remaining two quantities force and area of cross section. So we need to find out what will be the, so for which where the area of cross section is least. So how we will find out? So this is the graph A, B, C, D. A, B, C, D, X, Y. So let's draw a horizontal line. So suppose this is small a, small b, small c, small d. So now for all these components, F is same. Is not it? So we had L equals to F L by AY. So now since L is constant, Y is constant, and F is constant, so L is inverse proportional to 1 by A. So along this is the elongation, that is elongation or L. So since we draw the horizontal line, so on this line F is constant, so the final relation is the elongation is inversely proportional to the area of cross section, and we need to find out the wire having least area of cross section. So the wire which has least area of cross section will be having maximum elongation. So for area to be least, L should be maximum, and from the figure it is clear that for D, L is maximum, that implies A is minimum. So The correct answer is option D. So for where D, the area of cross section is minimum because the elongation is maximum at constant force, constant length, and constant value of modulus of elasticity. I hope this is clear to everyone. Now we move to question number 7. Question number 7 says 3 point masses, each of mass m, are placed at the corners of an equilateral triangle of side A. Then the moment of inertia of the system about an axis passing along one side of the triangle. So the triangle is given here. Here it is M, M, M. So let's name it as A, B, C. So we need to find out the moment of inertia of the system about an axis passing along one side of the triangle. So suppose this is A, B, and C. Here the mass is also present. Suppose this is mass M. Here is mass M, and here is mass M, and we need to find out the axis passing along one side. Suppose this is the axis. So this is the axis along which we need to find out. Let me change the color. So this is the axis along which we need to find out the moment of inertia of the system. The options are option A 0, option B 1 by 3 ma square, option C 3 by 4 ma square, and option D 3 ma square, where A is the length of the side. So what will be the value of moment of inertia? So I'll give you a few minutes. This is a very important question from the examination point of view. This type of question you will get. So this is based on the concept of moment of inertia. So we will discuss this question in details. So first I will let you to try this question and solve it, and then we will discuss. So if we discuss, we know from the concept of moment of inertia of a system, if we are talking about an axis, so it is sum of the product of mass and square of the distance of that mass positioning from that axis. So the moment of inertia I is equals to summation over I mi ri square. So now if we see this is the axis, suppose this is x prime, along which or with respect to which we are calculating the moment of inertia. So this is a b c m m m. So now since the masses at b and c, so now what will be the moment of inertia of the system? I will be m at a r a square plus m at b r b square plus m at c r c square. However, since the mass at b and mass at c, they are on the axis only, so for mb and mc, rb rc both are 0 because they are on the axis. So the sorry m a r a square, so mb rb square is 0, mc rc square is 0. Now the question comes, what will be the value of ra? So this is the distance ra, where this is a, this is a, this is a, so this length, this is a by 2. So what will be the value of ra then? So ra will be a square minus a square by 4 root over, so 4a square minus a square by 4 root over 3a square by 4 root over, or root 3a by 2. That implies moment of inertia of the particle which is present at a is ma into ra square, which is m into root 3a by 2 square, which is m into 3a square by 4, or 3ma square by 4. Now let me add another slide. So the total moment of inertia of the system will be ia plus ib plus ic, where ia is 3ma square by 4 plus 0 plus 0, it is 3ma square by 4. So the correct answer is 3 by 4 ma square. I hope this is clear to everyone. Now we will move to question number 8. So question number 8 says, a wheel is rotating with an angular speed of 30 radians per second. It is brought to rest in 5 seconds by applying a constant torque. If the moment of inertia of the wheel about its axis is 4 kg into meter square, then the work done by the torque in 3 seconds will be. So you need to find the work done. The question is given. It is rotating at an angular speed of 30 radians per second. So the angular speed is 30 radian per second, and it is come to rest by applying a constant torque of 5 second duration. and the moment of inertia of the flywheel is 4 kg into meter square, and we need to find out the work done. So the options are option A 1512 joule, 3445 joule, option C 986 joule, and option D 655 joule. So these are the 4 options. I will give you a few minutes to solve this question, and then we will discuss what will be the correct answer. So the wheel was rotating with an angular speed of 30, and then it came to rest in 5 seconds by applying a constant torque. So the final angular speed is 0 radian per second, and initial was 30 radian per second. So the acceleration will be omega I minus omega f by t. So 30 minus 0 by 5, which is 30 by 5 or 6 radian per second square. Now question says, then the work done by the torque in 3 seconds will be, if the moment of inertia of the wheel is about the axis is 4 kg per meter square. So now if the work is done for 3 seconds, then after 3 seconds what will be the value of angular, because it came to rest after 5 seconds of applying the torque, but we need to find out what is the work done by the torque in 3 seconds. So we need to find out after 3 seconds what is the value of angular momentum, sorry, angular velocity. So after 3 seconds, what will be the value of omega? So omega, suppose it's omega t, it will be omega I minus alpha t. So omega I minus alpha is 6, t is 3. So it is 30 minus 18. So 12 radian per second. So now what we need to find out, the work done by the torque. So the work done by the torque is equal to loss in the rotational kinetic energy. So work done by the torque equal to loss in rotational kinetic energy. So it will be half I omega 1 square minus omega 2 square, or omega I square minus omega t square. So half I is given, I is 4 kg into meter square, omega I was 30 and omega 2 was 12. So 4 by 2 into 900 minus 144. So it is 2 into 756, which is 1512 joule. So the correct answer is 1512 joule. I hope this is clear to everyone. Now we move to question number 9. Question number 9 says a sphere of mass m and radius r rolls on a horizontal plane without slipping with speed u. Now if it rolls up vertically, the maximum height it would attain would be, not necessary of considering energy loss due to friction. Options are option A 3u square by 4g, option B 5u square by 2g, option C 7u square by 10g, and option D u square by 2g. So the question says a sphere of mass m and radius r. Suppose this is a sphere, the radius is r and mass is m. It is rolling on a horizontal plane. So it is rolling on a horizontal plane without slipping and speed is u. Now it rolls up vertically, then the maximum height it would attain would be. So the total energy will be then converted into the potential energy. So here we need to find out what will be the maximum height. So these are the 4 options. I'll give you a few minutes and then we will discuss what will be the correct one. So when the sphere of mass m and radius r is rolling on horizontal surface, then what is the total energy that it's carrying? So the total energy will be rotational kinetic energy plus linear rotational energy plus translational kinetic energy. So total energy E is rotational kinetic energy plus translational kinetic energy, and we know rotational kinetic energy is half I omega square plus kinetic energy is half mv square. So I for sphere, we know it is 2 by 5 m r square, where m is mass and r is radius of the sphere. So total energy will be E half mu square plus half I is 2 by 5 m r square omega is u by r. So omega square, we can write half mu square plus half 2 by 5 m r square u square by r square. So r square gets cancelled out, 2 gets cancelled out. It is half mu square plus 1 by 5 mu square. So if we add both, it will be 7 by 10 mu square. So this 7 by 10 m square, when it is, so when the question says what is the maximum height? Suppose this is a inclination that it is climbing. So suppose it went up to here. So it stopped here, and the distance and the vertical distance traveled is h. So at the point h, its kinetic energy becomes 0. So the total energy E is kinetic energy plus potential energy at h. Kinetic energy is 0 because it went up to h only. So what is the potential total energy? Potential energy. So what is the total energy? Total energy is 7 by 10 mu square, and the potential energy is mgh, where h is the height it went up to. So h is equals to 7 mu square divided by 10 mg. So m gets cancelled out. H will be 7 m square divided by 10 g. So the correct option is 7 u square. Sorry, this is not m square, this is u square. So 7 u square divided by 10 g is the correct option, that is option C. So here initial energy was due to both rotational energy and translational energy. So we found the total energy is 7 by 10. So when it went up to a vertical distance h and then it stopped, so the kinetic energy becomes 0. Total energy becomes potential energy, and that is 7 mu square by 10 g. So h is 7 u square by 10 g. So I hope this is clear to everyone. Now we move to question number 10, which is the last question of today's interaction session. So question says, A, B, C are three equal point masses of M each, rigidly connected by massless rods of length L, forming an equilateral triangle as shown in the adjoining figure. The system is fast rotated with constant angular velocity omega about an axis perpendicular to the plane of the triangle and passing through A. Next, it is rotated with the same constant angular velocity omega about the side AB of the triangle if K1 and K2 are the kinetic energies of the system in the first and second case, then what will be the ratio of K1 by K2? Options are option A 2 by 3, option B 4 by 3, option C 8 by 3, and option D 10 by 3. So the question says there are three masses of M each. So M. Suppose the side is A. The question says the system is fast rotated with constant angular velocity omega. So omega is the angular velocity the system is being rotated about an axis perpendicular to the plane of the triangle and passing through A. So the axis is perpendicular to the plane of the triangle. Suppose this is the axis, or you can draw it. Suppose this is the axis which is passing through A, B, and C. So this is perpendicular. So this is suppose this is plane. So this is perpendicular to this line. It's plane. So this is the case 1, and in case 2 it is rotated about the side AB. So in another axis it is A, B, C, and they are being rotated about this axis AB, and the three masses are present here, A, B, and C. So this is 1, that is K1, this is 2, that is K2, and we need to find out what will be the ratio of K1 by K2. So I will give you a few minutes and then we will discuss what will be the correct answer. So let's solve the question. Suppose let's solve case 1 where the axis is passing through A, B, C, M, M, M. This is A. So what will be the moment of inertia in first case? So the moment of inertia will be summation over I M I R I square. So for A it's 0, which is IA plus IB plus IC. So IA will be 0. So for IB it will be MB A square plus MC A square, so which is MA square plus MA square, which is 2MA square. So what is K1? So K1 is half I omega square, half into I is 2MA square into omega square. Omega square is, so it is M A square omega square. This is equation 1. Now in the second case, case 2, what is the moment of inertia? Suppose this is the, and this is the axis A, B, C. Mass is here, here, and here. So I2 will be summation over I Mi Ri square. So Ia plus Ib plus Ic. So both Ia and Ib will be 0 because they lie on the axis. For C, what is RC? This is the distance RC, and RC we calculated, it is 3A by 2. So what will be I2? I2 will be M RC square. So M into root 3A by 2 square, that is 3MA square by 4. Let me add another slide. So I2 is 3 by 4 MA square. 3 by 4 MA square. That implies K2 is half I omega square, half into 3 by 4 MA square into omega square. So 3 by 8 M A square omega square. This is equation 2. So the ratio of K1 by K2 is M omega square A square divided by 3 by 8 M omega square A square. So M gets cancelled out, omega square they gets cancelled out. It is 1 by 3 by 8, which is 8 by 3. So the correct answer is 8 by 3, that is option C. So here K1, for K1 the axis was passing through A, so the moment of inertia of A will not contribute, and the remaining ones are B and C, so they contribute to 2MA square. And for second case 2, it is only contribution comes from C, because A and B they are lying on the axis, so the moment of inertia is 3MA square by 4, and the ratio of the two, because they are being rotated with same angular velocity omega, so the ratio will be 8 by 3. So with this we come to the end of today's interaction session. So I thank you all for joining in this course. So I hope this will help you in solving your assignments of this course and also for your exam. With this, I come to the end of today's session. That's it for my side. Have a good night.